Hello, my name is Philippa Gardner, and I'm a professor in Imperial College in London. Now, I work on programme verification. Now, this is quite an esoteric subject, so it's quite difficult to explain. Basically, it's trying to say what our software does and doesn't do. Is it doing what we intended? And how do we trust the answers to the questions we get? It's been a dream for a long time to use program verification to help answer these sorts of questions. People like Alan Turing, Tony Hoare, and Robin Milner from Edinburgh have all been trying to answer these questions right back since the start of our subject. And we are now beginning to get the analysis techniques and tools to a stage where we can bring answers to such questions right to the edge and even in industry, in the mainstream. This is our challenge, and this is where we're working. Software used to be closed. It was described using informal English prose and analysed with ad hoc testing. Now software is open, agile, continually evolving, and the traditional methods for describing it and analysing it don't work so well now, and we have to find new methods. So I work on analysing programs, and in particular, the program reasoning is compositional if we can sort of work with one function, one program in amongst this huge amount of programs that are going on in an industrial code base, for example. So here is a tiny program, and what does it mean to analyse it, to then take the analysis and record the results for others to be able to use? Now, we've known about this idea of compositionality, which has a very mathematical meaning, for a long time. But we haven't been able to sort of grab at the heart of it, which is, given a piece of code that manipulates the computer memory, what does it mean to analyse that? And we've just recently had a breakthrough with this work. The breakthrough is working with partial memory, not complete memory. And it was done by Peter O'Hearn and others in something called separation logic, where separation logic for compositional verification, and later something called incorrectness separation logic for true bug finding. And this was absolutely this key step of being able to work with small parts of the code base and then record the results that get used elsewhere. My contribution has been to bring abstraction to separation logic. In particular, it's called the fiction of separation. And what that does is that one is able to reason about, for example, just a set where you might have one bit program or many programs hitting at this set and taking elements out, putting elements in, changing what's going on with this set. And I can describe this at this very abstract level. But actually what's going on in the computer right at the bottom, it's just zeros and ones. And of course we tend not to work right at the bottom, but actually we have different forms of spaghetti for manipulating the memory in an efficient way to get a way to reason about and work with sets. And the point is, you don't need to know about this spaghetti. You can work at the level of sets and reason at the level of sets, and that's what the abstraction brings. So the first answer, this is totally not my field, but I can say some things. So I work on program verification of specific languages and specific types of code. So I am on the innards of the code. However, I'm doing this as part of this ecosystem of software infrastructure, and we're all of us going to have to handle what does it mean to have that black box over there, and what does it mean to be working with these neural networks, what does it mean to be working with ChatGPT. One easy answer is whatever code gets created by others, whether the others be a human or a machine or however, what does it mean to validate it to be used by yourself? And what does it mean to trust that? There's different versions of trust, whether it be, well, it's come from a trusted place, so one does a reputable company, or one knows the coder over there, so one trusts it in that sense. But now, because things are so open, one has this needing this stronger level of trust. And there's lots of discussion about how to cope with code when even the code developer doesn't fully know what's there, because some of it has come from GitHub or GPT or whatever. So suddenly one has to have different notions of trust and different notions of checking. And my work is about understanding how to check. It's not about delving into the specific things such as ChatGPT or neural networks and actually working out what's going on in the black box. But it is, given the results, what does it mean to trust what's there? GCHQ did something quite special about 8 years ago, which is, for the first time in my career, they put out a call saying program verification is important. Here's some money to do some work. Please bid for this. And I think there'd been a lot of work a lot of research calls in the past on this, some of which was used by Edinburgh to develop the laboratory for the foundations of computer science. So it's not that there wasn't stuff that hadn't happened in the past, but when I got going, there was a dearth of funding in this field, and it took a while to come back. And GCHQ understood that this was a really important subject. There were 6 projects, and they needed a director. And you asked to bid to be a director, and I didn't bid because I didn't want to be director. And it turned out I was arm twisted a bit to become this director of this 6-project research grouping. And this evolved into something called the Research Institute for Verified Trustworthy Software Systems, VETS. And I proposed and led this institute for 5 years with strong help and support from GCHQ. Meanwhile, inside GCHQ, they were employing people for the first time to look solely at verification. And they've only got 2-3 people. It's not very much. But what has happened over the process, for the time, is that inside GCHQ, there are people doing formal specification now. And that specification is going out to companies. And there are just the fledgling start of people verifying code against this specification. So GCHQ are really exploring this very hard. Meanwhile, there's this National Institute, VETS, that are bringing together academics, industrialists, and government employees, all interested in this specialized world of verification. And this is now moving forward. I've just stopped it. And there's British Dongle from Surrey and Azalea Rad from Imperial that are taking it to the next level. So we'll see what happens. So I started off in Oxford and I was doing a maths degree. And I was realising it wasn't quite my thing, but not quite realising what I should be doing. So I went to Bristol and did a course on logic and computation. That was a MSc. And actually, a dear friend of mine and I ended up going to Edinburgh from Bristol. And the only reason why I ended up in Edinburgh was because he knew how special Edinburgh was. And I thought I'd better go and have a look just to see what I was missing. And I ended up in Edinburgh too. That's actually quite a funny story because I got interviewed. I got offered a job there, a position as a PhD student then and there, which I wasn't expecting. And so I was walking around the corridor going, why am I going to come to Edinburgh? And I met somebody called Mads Tofte and Mads Dan. And they're sort of famous people from my time in Edinburgh. And they were going to play badminton. And I went up to them, and they're two huge 6-foot-something Danes. And I went up to them and said, why should I come to Edinburgh, given this precocious youngster way of doing things? And Mads Tofte said to me, go and look at the web pages. Stop being such a blithering idiot. Go and find out what you'll be missing if you didn't come to Edinburgh. I ended up in Edinburgh and had some wonderful years playing badminton with the two Mads and one of the Mads' wife, Charlotte, and myself. It was the most joyous time. And then, yes, so there's more, isn't there? So I got to Edinburgh and then have the agony as to whether to be an academic or whether to do other things. And during my time in Edinburgh, I decided, right, I'm going for it. And why does anyone do that? Because it's an extremely difficult career path. But somehow I had the steel inside to go, I'm going for it. And I ended up going from Edinburgh to Cambridge to Imperial. I actually, at some point, tried for a job in Edinburgh, and I didn't get it. And I was half devastated and half not devastated because Edinburgh was so wonderful about making me feel okay about not getting the job. And I think that's something that's absolutely special about Edinburgh, that they looked after the people they had, and it was just whether my face fitted. And I know exactly why I didn't get it and exactly why the person who did get it should have got it. And over the years I understood that, but at the time it was quite difficult to understand. So, and Edinburgh were wonderful about that. So I went Edinburgh to Cambridge to Imperial. I had one last-ditch attempt at some point, and that was to get a very difficult fellowship in Cambridge, and that's what I got. And I held my nerve and got what I wanted, and that was extremely difficult. And at Cambridge, I had a 5-year position. And year 3, I decided I was never going to be as nervous again as how I had been in Edinburgh. So I started looking in year 3 for the institutions I wanted, and ended up going to Imperial in year 3 and lucking out because my face happened to fit that place. And it was the best move I've ever done because I came as a theorist with my mathematics degree, and I turned into somebody that could work well with the Imperial students. And the Imperial students are wonderful. They are extremely good coders because we teach that very well. And some of them are also interested in theory. So suddenly I had to evolve and turn into this combination of theory and theory through to practice. And over the years, that's what's happened. And even though in my temperament, I'm quite focused, mathematical sort of person, I've ended up quite broad because of all the inspiring inputs from the students. there's a real sea change going on. So it used to be that it was about industry with this specialist niche of we need to do software really, really well for some reason. And one example of this is Altran UK, where the UK air traffic control system has been fully verified by them, and they have a contract that says if there is a bug, we will fix it by yesterday. There is very tight contract, and I gather it's a huge success in that field. So, but that was sort of before. And now what happens is ideas from verification and bug finding have got into the tech companies. The tech companies are the huge companies where there's enough money around to be able to look at this sort of infrastructure work. And in particular, I'm talking about groups like Meta and Amazon and tech companies like that, where now in the actual software design process, there are tools run using the sort of techniques that I work on that absolutely are integrated with what's called continuous integration and give back error reports to general developers. And part of the industrial process is as the code gets certified and put into the big repository in, for example, Meta, part of that certification is that they have to say which of these errors they're going to pay attention to and which they are not. Oh, goodness, that's a hard question. So basically, Edinburgh made me who I am today. That sounds ridiculous, but in some sense. But at the same time, this was my home, and I still have this broad grin on my face because I found it so special. And I was surrounded by people of my generation that are now all around the world being the senior figures of the highest caliber. And I think there's so many ways to say why, but I'm going to concentrate on Rod Burstall, Robin Milner, and Gordon Plotkin, who is a PhD student of Rod Burstall. Now, they, with others, created the Laboratory for the Foundations of Computer Science. But that doesn't really say why they were so special. They were awesome in their work. So much of the work that is happening today in my field and much wider has come from these guys. But I just want to... I was a PhD student of Gordon Plotkin. I ended up going to Cambridge and working with Robin Milner. But the one I want to focus on is Rod Burstall. So I was doing a talk. It was my first talk about my subject. And I was extremely nervous and did a terribly bad job. And Rod Burstall took me aside and went slowly through what does it mean to give a good talk. So even though I was Gordon Plotkin's student, Rod Burstall knew that he was the guy that was right to tell me about how to give a good talk. So there was some sort of... The three of them were working together as well as being individuals doing their own research. And I think that was so special and was the reason why the laboratory was and is such a success. There was another example, which is the guy, James McKenna, who was with me in Bristol. He and I both applied for a fellowship at some point. And Rod Burstall said, if James gets the fellowship, then I will give you money to be okay and to continue. So Rod was again thinking about more than just his group. James was with Rod. And in the end, we didn't expect it because it was devastating. There we were competing with each other. But actually, we both got the fellowship. So the best outcome happened. But really, that was about Rod. It was say, he could have gone for the person who most helped Rod for his work. But instead, no, he thought wider than just his group. And it was fantastic. So actually, when I came up to give this Robin Milner lecture recently, I felt immediately at home. There were all my friends again, but but as well as the next generations moving the field forward. And I think I've lost a bit my connection with Edinburgh, and that's actually just because, especially in this modern world, everything is so busy that we're having to sort of really work hard where we are. And I realised this was exactly the wrong thing to go, and I have been absolutely daft to lose my connections. So I happened to be in Glasgow this weekend and purposely came back to rekindle what's my connections with Edinburgh. And in particular, I actually have something that's happening right now. So Robin Milner is the person who advocated formal language specification, meaning you have a book which is the definition of the language rather than informal prose and examples to show you how particular commands work. And he did this based on work that Gordon Plotkin did on structural operational semantics. Now, since then, there's been a lot of work on handwritten formal specifications, then moving on to mechanized specifications to work with larger languages. But what's been happening is that the mechanized specifications have been happening after the fact and have, after the language has been created, and often it's partial. I did some work on JavaScript mechanization. I did it for a huge part of the language. They doubled the language the next year, and so I couldn't keep going with that work. So, but there's something very special that's happening recently, which is there's a language called WebAssembly that is used in all the major browsers. The last language to be used in all the major browsers was JavaScript. This WebAssembly is actually very important. And the special thing about it is that it uses formal language specification just as advocated by Robin Milner all those years ago. And I, with Conrad Watt in Cambridge, have been doing the mechanization of WebAssembly. And we are up with the standard at the moment. We don't know how long we can keep being up, but right now we are very connected with it, to such an extent that Conrad Watt was changing mistakes in the formal specification before publication, and it was able to correct them so that the formal methods agenda was really something that was grounded and tight, rather than something with mistakes. He did super work. So what's happening now is something quite special. There's a new approach to formal language specification being proposed. And it's called, at the moment, WASM DSL. That might change, domain-specific language. And the idea is that you have the language and you get automatically the English prose, the test suite, and the mechanized definitions. Then we have to work hard to prove correctness results that the mechanized definitions are good, different versions of good. What do I mean by that? Well, Robin Milner, in all those years ago on Standard ML, did type correctness and module instantiation. Conrad Watt showed that type correctness was not correct for the WebAssembly specification, formal specification, and solved it before the official publication, and now he and I have done this module instantiation that was just too hard to do without the mechanization. So we've got this new way of thinking, which is this WASM DSL, and what does it mean to actually let the help the mechanized specification and the correctness results keep track with the standard. We don't know how far we're going to be able to go. We do know that WASM DSL is important because you can get English prose for free, which means that very few specialists don't have to write English prose all the time. So we know it's going to be useful, but whether we can get the mechanization to keep track with the standard, that's the challenge we have. And there's Sam Lindley in Edinburgh and Matija Pretner from Ljubljana, who is a PhD student of Gordon Plotkin and now works with Sam. Those two are also part of this WASM DSL group. There's only about 10 of us, and I'm working with them over the next couple of days to see asking the challenge and the questions, what on earth does it mean to get this mechanization to keep track as the standard evolves. So actually, one thing that struck me when we were preparing for this video was that you were warning me that if there was some noise out in the corridor, we would have to stop for a bit and pause. That hasn't happened, but you were warning me of this. Well, actually, my hobby is singing. I do a lot of it. It's classical music, whether it be early music right through to contemporary music. I still have singing lessons, and there's this most wonderful ecosystem of music going on in London, and it's a wonderful place for me to do this hobby. But in particular, when you're recording, absolutely, you've got to cope with the noises off. And so I was sniggering a bit when you were saying that earlier, because I'm very familiar with having to pause whilst people go through the corridor or equivalent. Usually it's buses or motorcycles. There is one thing I'd like to say. So I was at Kingsbird Buildings working in the computer science department, and working in this world of programming languages, formal specification and verification, and type systems where you're doing little bits of properties embedded inside the programming languages. And actually, there was this wonderful grouping of the type theory people inside the computer science department, the type theory people, the type systems people inside AI. I'm thinking of Alan Bundy's group, and a group of PhD students and postdocs interested in typing in cognitive science. And we had a lot of meetings between these three groupings having to be in Edinburgh or in the AI department or the cognitive science department. So for example, Alan Bundy, who headed AI for a while, he was my internal examiner for my PhD thesis. So it's absolutely really close given these subjects. And something that is so special is the fact that these departments have now come back together and are in informatics right in the heart of Edinburgh. Whenever I come back here, I have this absolute excitement that you guys are just where you should be, right in the centre of things, as part of this huge site focusing on informatics in the widest sense.